Our video tutorial this time is about binomial theorem. We are familiar about expansion of the binomial x plus y raised to the second power and third power, or the square and the cube of x plus y. We notice that in every term, the sum of the exponents of x and y is always equal to the exponent of the binomial expansion. So 1 plus 1 is 2 here, 2 plus 1 is 3, 1 plus 2 is 3. But when the exponent of the binomial is more than 3, let us in n is element of natural numbers, a and b are element of real numbers, then if the binomial a plus b raised to the nth power, it is equal to the summation of the terms, where inside the parenthesis in g is the coefficient of every term in the expansion of the binomial. The exponent of a and b can be interchanged. This is n minus g and b is raised to g, or a is raised to g and b is raised to n minus g, as long as the sum of the exponents of e and b is always equal to n, or the power of the binomial. We are particular about the coefficient of a certain term in the expansion of the binomial a plus b to the n. So here inside the parenthesis, this is taking the combination of n taking g of a to the g b raised to the n minus g. Let us illustrate this one in an example. This is the expansion of the combination. For example, find the coefficient of x to the 6 y to the 4th in the expansion of x plus y raised to the 10th power. So we are asked to determine the coefficient of x to the 6 y to the 4th. We notice that the exponent of the binomial is equal to 10. N is equal to 10. So 6 plus 4 is equal to 10. Our n is 10. In our combination 10, our n is 10. Then 6 is the exponent of the first term. We expand this in the by combination 10 factorial over 6 factorial times 10 minus 6 factorial. 10 minus 6 is 4. Expand the factorial. 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. 4 factorial is 4 times 3 times 2 times 1. 6 factorial is cancelled. 4 times 2 is 8. Cancelled out 8. 9 divided by 3 is 3. Then we are left with 10 times 3 times 7, which is equal to 210. So the coefficient of x to the 6 y to the 4th is equal to 210. Another example, find the coefficient of x to the 6 y to the 7 in the expansion of x squared minus y to raised to the 10th power. We know that x to the 6 y to the 7 is the same as x squared raised to the 3rd power y to the 7. So that 3 plus 7 is equal to 10. So our coefficient will take the combination of n is 10. 3 is the coefficient of the first term. So in combination, 10 factorial over 3 factorial times 10 minus 3 factorial. 10 minus 3 is 7. Expanding the factorial, 10 up to 7. 10 times 9 times 8 times 7 factorial. 3 factorial is 3 times 2 times 1. We can cancel out 7 factorial. 9 divided by 3 is 3. 8 divided by 2 is 4. What is left is 10 times 3 times 4. It is equal to 120. So the coefficient of the term involving x to the 6y to the 7 is 120. X to the 6y to the 7. Another example, find the coefficient of x to the 8 in the expansion of x squared minus 4 raised to the 6th power. So here, x to the 8 is the same as x squared, because in our original binomial, we have x squared as the first term. So x squared raised to the 4th power is x to the 8. Then, the second term, negative 4 raised to the second power. So that 4 plus 2 is equal to 6. So this is 4, then 6 minus 4 is 2. So we are left with finding the coefficient of this term with x to the 8th power. So our combination is n, which is 6, and 4, the exponent of the first term. So taking the combination, this is 6 factorial over 4 factorial times 6 minus 4 factorial. 6 minus 4 is 2. Expanding the factorial, 6 times 5 times 4 factorial over 4 factorial 2 factorial is 2 times 1. Cancelling out 4 factorial, 6 divided by 2 is 3. So we are left with 3 times 5 times 16 x to the 8th power. So it is equal to 240 x to the 8th. So the term involving x to the 8th has a coefficient of 240. Example. Find the coefficient of x to the 8th in the expansion of quantity 2 minus x to the 10th power. Okay, x to the 8th in its term of the binomial, the first term is 2. The first term is raised to the second power, so that x to the 8th is the same as negative x raised to the 8th. Okay, so we need to determine the coefficient of this term involving x to the 8th. So we have here n, 10, and the exponent of the first term is 2. So taking the combination of 10 by 2, so expanding the taking the combination, this is 10 factorial over 2 factorial times 10 minus 2 factorial. 10 minus 2 is 8. Expanding the factorial, 10 times 9 times 8 factorial. 2 factorial is 2 times 1 times 8 factorial, cancelling out 8 factorial. 10 divided by 4 divided by 2 is 2. So we are left with 10 times 9 times 2 x to the 8th. It is equal to 180 x to the 8th. So the coefficient of the term in the expansion of this binomial, 2 minus x raised to 10, the term with x to the 8th has coefficient 180. Next example. Find the coefficient of the term involving y to the 6 in the expansion of y plus 1/2 raised to 12. Okay, so this is y to the 6. Since this is 6, 12 minus 6 is equal to 6. So the second term is raised to the 6th power. So that 6 plus 6 is equal to 12. So we need to determine the coefficient of this term that has y to the 6. So taking the combination of 12, taking 6, it is equal to 12 factorial over 6 factorial times 12 minus 6 factorial. Y to the 6 times 1/2 to raise to the 6th power. 12 minus 6 is equal to 6. So expanding the factorial, 12 up to 6, 12 down to 6. So, and 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Cancelling out 6 factorial. To 6 times 2 is 12. Cancel out with 12. 8 divided by 4 is 2. 9 divided by 3 is 3. 10 divided by 5 is 2. Then we are left with 11 times 2 times 3 times 2 times 7 divided by 64. Y to the 6. There is still common factor between 12 and 64. Cancel the common factor. Then we are left with 11 times 3 times 7, which is equal to 231 over 16, y to the 6th power. Next example. Find the constant term in the expansion of binomial t cubed minus 2 over t cubed raised to the 10th power. Okay. So that we can cancel out t, 10, the exponent of the binomial must be divided into 5 by 5, so that when t cube is raised to fifth power, and so with the denominator t cube raised to the fifth power, they must have equal exponent and they can be cancelled out. So we are left with finding the coefficient of this term. So our n is 10. The exponent of the first term is 5. So taking the combination of 10 by 5. So 10 factorial over 5 factorial times 10 minus 5 factorial. This is t raised to 3 times 5 is 15. 2 to the fifth is 32. T cube raised to the fifth is t to the 15. Negative raised to an odd power is negative. So we can cancel out t to the 15 so that there is no more variable. We are left with only the constant. 10 minus 5 is 5. So expand the factorial. 10 down to 5 factorial so that we can cancel out 5 factorial. And another 5 factorial is 5 times 4 times 3 times 2 times 1 times negative 32. Okay, cancel out 5 factorial. 4 times 2, or rather 5 times 2 is 10. Cancel out 10. 8 divided by 4 is 2. 9 divided by 3 is 3. So we are left with 3 times 2 times 7 times 6 times negative 32. So the constant term is negative 8064. Okay, that's enough.